There we are. After
Yay.
what? A few weeks of absence, I guess.
Yeah, but Chris has something to discuss.
I don't have
Yep.
time to discuss. I have a sermon to give from the
You've
mount.
got a statement
All
to
right.
make.
All right. So that tells me I have at least 30 minutes of time that I can use for doing something.
Alex
You
is
go
not
ahead.
paying attention because he's working on something far more interesting, apparently.
There will be questions at the end, Alex.
Yes.
Cool.
So, as part of working on issue 350 in GitHub, which is about providing a service that allows for thready things, asynchronous execution of stuff, doing things outside of the call of thread background tasks, blah, 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 and everything of that ilk. I started looking at the parts of Ehcache that use low-level thread abstractions, i.e. threads themselves generally, in attempts to twist them and make them use high-level abstractions, things like executors and scheduled executors, and stuff like that. And the first thing I targeted was right behind. And in the grand scheme of yak shaving or thread pulling, I started pulling threads in right behind and finding lots of things. So we found a lovely bug. It's 5 years old. I probably shouldn't admit that in public. It's fine because I didn't write it. And the person that wrote it isn't here anymore. Alex isn't paying attention.
No, he's not. He just pays attention when you say his name.
I know. I could have accused Alex of writing the bug. I don't think Alex was here actually when the... What? No, Alex was here when the bug was written. Well, not that old, quite. Around batching, which was fixed and has been backported to a bunch of 2x lines, and will get releases on current lines. And if you depend on open source, you can pull the fix straight away and build your own version. Blah, blah, blah. On the really old lines like 2.6 and stuff, it's on 2.6 forward. There's probably the only change on that line since the last release. So if you wanted to pick it up, if you're using right behind and you care, you can pick it up. Anyway, and the other thing I discovered in the act of doing this is that there's an awful lot of functionality in right behind. But a lot of it is orthogonal to the right behindness. And so in the process of looking at this stuff, I wanted to so because what I was having to do was rewrite right behind. Because I'm lazy, I wanted to limit the scope of what I was rewriting, and so we ended up ripping, or I've ended up. Did I already know? I haven't ripped anything out yet, have I? It's not actually merged. I want to rip out two things: retry and rate limiting. And also push the operation filter deeper. And I kind of talk about it now because we wanted something to talk about, but also because I wanted to sort of throw this out there and see if anyone that listens to this live or is going to listen to this later screams their head off and says, I really need rate limiting or retry.
Yeah.
So retry, I'll quickly describe what the two features do. Retry basically says, in 2x and in the early releases of 3, if you're using right behind and you've got retry enabled, if your writer throws an exception at us to indicate that something failed, then we catch your exception and infer what failed. Now there's this whole bulk cache writing exception thing which can communicate partial failure of a bulk operation. So we do special things with that about not retrying the things that succeeded. But in any case, basically, if it detects failure to write because of an exception throw, either of the whole batch or of part of the batch or of the operation, if it's a single operation thing, it will sleep for a certain amount of time, which you configure. And then after having slept, it will retry it. The idea being that maybe the network was down and I couldn't talk to the database, or somebody restarted the database, or who knows what. The idea being that hopefully, I hope this is all recording because I'm building stuff in the background. The idea being that hopefully after the retry it succeeds. And then there's this whole, because of that, there's obviously a cap to how many times it retries. And when it hits the cap, you have to have a special method that you call to say, oh, well, I retried as many times as I was told to retry and I still couldn't succeed. So now I have to tell you that I couldn't succeed. And so you call this method called throwaway. In 2x, throwaway was actually a method on cache writer. In 3, and I don't know how this transition happened, throwaway became a method on a secondary interface that you had to implement, although it wasn't really very well communicated, in my opinion, that was what was intended. But in any case, if your cache writer or cache loader writer in 3 speak, sorry, implemented resilient cache writer or something like that, then it would cast it to that and call the throwaway method, which was the single method on that interface, and say, I'm throwing away this key value pair that I failed to write, or the key that I failed to delete. So that's retry, and the whole thing with retry, of course, is that this is all being done in line with the write behind thread, and so the fact that it's done inside the write behind code and not inside the writer is just a matter of inverting the stack. So what I've done is ripped it out and said, you want to do retry? Write the code. Stick that for loop inside your cache loader writer and do it there. Now, the obvious thing then is, oh, well, I don't want to do that. Well, then there's nothing to stop us, if we want, writing a wrapper that can wrap any arbitrary cache loader writer that does all the same retry logic that we already had, and maybe something fancier, who knows. And we can also make that wrapper only wrap instances of an interface that has a throwaway, blah, blah, blah. So that's retry, and we think that retry can be pulled. So basically, I pulled it out and said, if people use this and want this, then they can do it with a wrapper. And then I make the statement that I don't think anyone uses it. And that's not a statement that I make because I'm informed. It's a statement I make because if I'm not informed, my default position is that nobody does this. So if you don't scream your head off that you do this, then it's possible that we don't ever write that implementation. And the plan is, or at least my plan is, that I won't ever write that implementation until someone asks for it. And then probably if the first person asks, I'll tell them to do it themselves. And then eventually when the nth person asks, at some threshold we'll decide later, we will actually do it. Or if they offer to pay us money, obviously. So that's retry. In the same scheme, rate limiting was this feature that allowed you to limit the rate at which you would write to the cache writer. And what it was actually doing was effectively, assuming that your batch sizes are stable, which they should be, roughly, then what it was actually doing was preventing two different batches from being written too close together in time. So it's basically enforcing a certain amount of idle time between each batch, which, when you average it out over large periods of time, becomes rate limiting. Of course, it makes the rate very bursty, but presumably you can cope with that. And the way that was done was basically the write behind thread would grab stuff off the queue, grab enough stuff off the queue to have a batch, possibly grab more than that, but that's implementation detail. And then it would have a look to see how long it's been since the last time it wrote anything. And then it would look at the size of the batch it's got or it's about to write and say, oh, this is too big. It's not, given how big this batch is, it's not long enough since I last wrote something for me to be allowed to write this. So then it throws it all back into the queue and forces itself to go round another sleep cycle. And then when it comes out, presumably it gets to write. And of course, all that's really doing is leaving stuff in the queue for longer and therefore applying back pressure on the puts, and eventually the queue will presumably, if the arrival rate of the puts is higher than the rate at which you've limited the writer, the queue will back up and your puts will block and you'll throttle the upstream process and prevent things. And so you get to provide back pressure and you get to protect your database. But it's the same argument with retry. You can just move that throttling into the writer itself, and if the writer just takes too long, you'll tie up the write behind thread, which means the queue won't get drained, which means the queue will back up, which means you get back pressure on the putting threads, and you throttle everything naturally. Because the queue is bound, it's the only thing that can happen. And so I made a decision to rip that out too and make the same argument. You want this, implement it yourself. And obviously if enough people, and we'll go with the default that nobody does it. And then when we find out lots of people use it, because you guys scream about it, we can go and decide to write a wrapper. There is the problem of what form these wrappers take and whether they are configurable through XML and where they're found, and is this some kind of, I don't know, service or what, I don't know. But this is something that I'm going to cross, a bridge I will cross when we get there. What this does do is massively simplify, well, not massively, but it simplifies XML configuration a little bit, and it greatly simplifies the right-behind implementation. Because all it's dealing with now is the delay, the batch size, the queue size, and writing. And there's no retry logic in there, and there's no extra rate limiting and all that stuff, which makes my task simpler. So I've done an enormous amount of yak shaving in order to simplify the inversion of the right behind, which is almost done.
And I think it makes sense.
And Louis thinks it all makes sense. And Alex wasn't listening.
No, but given the kind of bug we found, given we probably have very few users of that feature, it still is a useful feature if you want to implement write through and not pay the price of writing on every put.
Yep.
But indeed, I mean, you're better off knowing what to do when we fail, when the write fails. I mean, it's better if you handle that inside your own loader writer logic. So,
yeah. I mean, the other thing to be clear is that
kind of backporting this shaving back to the 2x line, obviously. So this is, and it just means 3.0 will most likely, unless somebody like Chris said, screams, will not have the feature initially. But again, we have options to add it.
Yeah, and the other thing to remember is that the retry being stripped out right behind gives the user the freedom to implement it exactly how they want. They can have exponential back off if they want on their retry. They can have it failure to write one system of record. Maybe they have some other backup decision. They say, well, the retry goes to somewhere else. Maybe I write to some file on disk that I later on read and look at and subsequently push things. Maybe I log to some special location. Like you're not forced to retry the same thing. You can have a really complicated write. Maybe you could always have that before, but you wouldn't have been using retry at that point, in which case it makes the retry feature kind of redundant. It's the same thing with the rate limiting. The rate limiting before was a little crude. Now you get the choice. You can obviously artificially rate limit. You can let the thing that you're writing to provide back pressure to you, and so on. Like exactly how you provide the back pressure and in response to what's happening in the system is your choice. My suspicion is that neither of these features are used because I don't think that they were flexible enough to be useful to everyone. Plus, I don't think. But as Louis said, based on the bug we found, I'm not. Well, to be fair, you have to be not coalescing, which is a little unusual. But anyway, there you go, Alex. I burnt almost half an hour.
Yep, that's good.
So that's one thing. Another topic we wanted to discuss was about moving this meeting.
Oh, yes.
Using the same time, but move it to Tuesdays.
Because
now that's cool, because saying using the same times actually work for all time zones.
I don't think I don't think there's any places that use a different time zone on Tuesdays.
Yeah.
Or Thursdays, for that matter. Which is obviously fine by all the people in this meeting.
Yes. So vote. Agreed. Alex says
what Alex thinks.
2 against 1, so.
So this will move to Tuesday, which obviously doesn't affect anyone that watches it. Well, only marginally affects anyone who watches it recorded. If anyone is watching live, I can't tell because I'm not Alex. Then we won't be here next week. But then we weren't here last week, so. And hopefully next week, the right behind will be complete.
Yeah. And so. To give status, what we're doing for the moment is working on that milestone 4 that we want to be once more slightly conference driven. So the aim is to release it during Java 1.
4. We're actually going to release it during?
I'm saying during. Before, if we can make it.
Is that because you think it's a nice big stunt to pull, or are you saying that because you're pessimistic about us getting it done beforehand?
Yeah. Joker, not answering. No, just to be realistic. I mean, we want development to be done and testing.
And what's happening at Java 1? Alex is talking.
So we have one talk by Alex on GSR 107 and going beyond GSR 107.
Which is when, Alex?
I don't know.
You pasted
During
the-
Java 1 in some hotel.
Wasn't it Tuesday? No, it was Monday.
I don't know. I saw the date, but I didn't map it to an actual day of the week, so I don't
It was
know.
the same day as mine. Mine's Monday. I think yours was Monday at like 11 or something in some hotel somewhere. Louis being
Yeah, I'm
managerial and
switching.
looking it up.
So it's the 26th, so that's Monday indeed, from 11 to 12 Pacific time, in the Hilton Golden Gate 2/3 room. And so it's going to be Ehcache 3 GSR 107 on steroids.
And
That's
then
one.
after you've
Then-
had great fun at Alex's discussion, you can come meet everybody at 7
Yep.
in the Park 55. Now, there's multiple Park 55s, right? Or there's multiple
It says
rooms.
mission, Park 55 mission.
Okay, I assume that's a room inside it,
That's what I'm going to assume too.
which is a hotel, obviously in the Java 1E area, as it's become,
Yep.
where we will talk about Jcache 2.0. Hopefully, there will be lots of people there.
Yep.
Well, obviously, the three of us will be there.
The
even
three
if I
of
have to
us,
smuggle
I
Louis in.
guess Brian Oliver, who's the co
Brian Oliver, who's
speaker,
our
and
coherence engineer.
I'm expecting the Hazelcast.
Yeah, I anticipate from the fact that Chris Engelbert responded on my plea for things to talk about that he will be there. Hopefully, Greg may be there. I don't know. Steve Millage is talking at Java 1 and chimed up about it, so maybe he'll be there. He's Payara guy, the enterprise glassfish. For those who don't know, is very obviously interested with Java EE integration. So if you have any opinions on things that are wrong with 107 that you would like fixed, or directions you'd like a successor to 107 to go in, then come talk about it. And we'll probably go to a bar afterwards or something where you can imbibe in an alcoholic or non-alcoholic beverage. There was probably a thumbs up to the alcohol from Alex. Cool. Now we've burnt exactly a half an hour, pretty much. Don't know if there's anything else to bring up. Are we done?
So, yeah, what we can say is that we're hoping milestone 4 will be like closer to API-wise. At least, well, clearly the Ehcache API doesn't change, but even configuration-wise, it'll be closer to what we want the GA to be. We have a few features that are outside of milestone 4, and we probably need to do some work on the milestones, because for the moment, I guess the 5 says clustered, but that's going to be slightly different. But so we have a number of features that we've pushed out because we believe clustering has an impact on them, and so we want clustering to be ready before we work on that. And they're mostly everything that relates to pools of resources, so the automatic resource control of Ehcache 2x. And the second one is the new Ehcache 3x feature, which is resident strategy, and the fact that we want users to be able to configure them or choose them. And the exact way this is going to look like is not completely fixed for the moment, but we clearly believe that clustering is going to bring a new dimension to that feature, and so we want that to be in the picture before we finalize this. And because the plan is still to have an Ehcache 3.0 that includes both clustered and unclustered. Although the exact set of features on each of the two major differences is not set in stone. So, yep. And then if we're talking conferences, after Java 1, there is 1 week back to work, and then there is Devoxx in Belgium. And there, Alex and myself will be having a caching university session of 3 hours. Chris is talking also, showing the internals of OffHeap. And I think you're also hosting a BOF.
I'm hosting another BOF, yeah. But not about caching. So
Go check
Wow.
Devox Belgium program
Yeah.
if you're interested. And the week
Alright.
after that, I'll be in Devox Morocco doing the Ehcache 3 GSR 107 on steroid session. There. That's for the upcoming stuff. And we're hoping that we make progress on clustering over the coming weeks so that we can really start having public meetings around everything that relates to clustering and how it's
Yes.
going to look like and etc. etc.
Cool.
That's it.
Now, if Alex will stop looking at his monitor and coding whatever he's coding, he can end the meeting.
Decide if we want to keep on going or end.
While it remains live, I'm going to keep talking every now and again.
I totally agree with everything you guys said. And
Oh,
that's
so you
it.
Yes. Whoa. That's a
a
dangerous
gallon
statement.
of beer
Oh,
each.
that's not recorded though.
Yes.
All right, cool.
Thanks.